Section 11.6 is about recursion and special sequences. One of those special sequences we're talking about is this one, the Fibonacci sequence. We've talked about it before. The Fibonacci sequence is created by, if you look at a term and you add the two terms that come in front of it. So in this case, 3 plus 5 equals 8. This is an example of a recursive sequence and is found by using a recursive formula. And that's a formula in which each term is formulated from one or more previous terms. This is the recursive formula for the Fibonacci sequence. It says that, for example, the sixth term is created by looking at the fourth term plus the fifth term. So just rewriting it this way, a sub 4 plus a sub 5. And that's what we did here. We added a sub 4, the fourth term, and we added a sub 5, the fifth term, to find out what a sub 6 was, the sixth term. That's how the Fibonacci sequence works. Now, every recursive formula is different. This is just the recursive formula for the Fibonacci sequence. Here we're asked to find the first 5 terms of a sequence. We know it's a recursive sequence because it has a recursive formula. So I know that the first term, a sub 1, is going to be a 4. So I'm going to use that then to find the next 4 terms that come after that. So if a sub 1 is 4, then I'm going to say a sub 1 plus 1 is 3 times a sub 1 minus 2. And so I'm really saying that the second term is 3 times a sub 1, which is 4, minus 2. And so that's going to give me a 10. So now I know that a sub 2 is 10. By plugging in a sub 1, I'm able to find that. Then I'm going to say a sub 3. Actually, let me do it this way. A sub 2 plus 1, because now I'm going to use n of a 2, is 3 times a sub 2 minus 2. Plugging those values in, I get the third term of the sequence is 3 times 10, because that's what a sub 2 is. It's 10. I got it from right there, minus 2. And so that's going to be a 28. So I know the third term of my sequence then is 28. In the next one, I'm going to find a sub 3 plus 1, or a sub 4, and I use that by multiplying 3 times the third term. Well, the third term is 28, so I plugged it in, subtracted 2, and I got 82. So the fourth term of my sequence is 82. And then the last term, a sub 4 plus 1, equals 3 times a sub 4 minus 2. So the fifth term of the sequence is 3 times 82, which is the fourth term. Subtract 2. You get 244. So writing this out as a sequence, 4, 10, 28, 82, and 244 is my recursive sequence. Here we're given the definition of iteration. Iteration is the process of composing a function with itself repeatedly. Remember, a composition of functions is when you take one function like f and g and you put one inside of the other. That's what a composition of functions is. Well, iteration is when you take a function and put it inside of itself, in this case. Or you could even do it multiple times. Did I have enough of those? Yeah, you put a f of x inside of f of x inside of f of x inside of f of x, and in theory you can do that forever. That's what an iteration is. Now, what you're always going to be given is you're going to be given an x sub 0. This is called the initial value. And then you'll take that initial value and you'll find the first value of x by plugging that initial value into your function. Then you're going to find the second value by plugging that first value in for the second value. So you plug the x sub 1 into the function again. Another way of thinking of that is f of x sub 0. So you take f of x sub 0 and plug that again inside of f of x. I'll do one more just to show you the pattern. So this is f of x sub 2. So you plug the last value into the function again. The other way of thinking about that is the composition of the function 3 times. And this is what iteration is, taking a value for a function and using it back inside itself multiple times. So here where we're asked to do some iteration, we're asked to find the three iterates of this function, f of x equals 2x plus 3. We're given the initial value x sub 0 equals 1, like I told you we would. So now if I want to find x sub 1, I'm going to take my function and put x sub 0 inside of it. And since x sub 0 is 1, I'm trying to find f of 1. And what I do is I plug that into my function. 2 times 1 plus 3 is going to be 5. So we say x sub 1 is now 5. Now to find the next iteration, x sub 2, we're going to take my function again, the same function, and we're going to put x sub 1 into it. Well, we know that x sub 1 is 5, so we're really finding f of 5, and we're going to plug that into our function. And 10 plus 3 is 13, so we now know that x sub 2, or the second iteration, is 13. We're repeatedly using the same function over and over and over with the last value. Finally, x sub 3 means we take x sub 2 and plug it into the same function again. X sub 2 is a 13, so we plug that in, and we just replace x with that. And 26 plus 3 is 29, so x sub 3 is 29. And this is an example of a sequence that's created using iteration.